Hello again, and welcome to Investigation 8, the final investigation of Foth's Earth History Kit, called One Rock to Another. Up until now, students have been only exposed to sedimentary rocks and sedimentary rock processes. And then we moved on to geologic time and looking at fossils and index fossils. Now we're coming back to rocks again, and we're going to introduce the students to two very big ideas. So this is a very important investigation. Students are going to be introduced to the rock cycle and looking at igneous and metamorphic rocks, and then they'll be briefly introduced to the concept of plate tectonics. Unfortunately, this is one investigation that you will most likely want to beef up on your own, and I'll talk about that more towards the end of the video because it is a little bit light, too light in the area of plate tectonics, something that is definitely in the state standards and frameworks, and you will want to make sure that students get some resources for that. The investigation comes in 4 parts and takes about 1 to 2 weeks, depending on how deep you go in certain sections, especially some of these latter sections looking at neighborhood rocks and local projects, which I'm not going to talk about today. I'll talk a little bit about part 3, but it really is variable on your end. Part 1 is going to introduce students to the other 2 types of rocks, as I mentioned earlier, igneous rocks and metamorphic rocks. It's a fairly straightforward activity where students will use their resource books to attempt to identify and to learn about the rocks that are presented before them. The students will look at the photographs, will look at their actual rocks, and will read these descriptions and try to log them into their lab worksheets. I definitely encourage you to encourage the students to take the time to read these descriptions, particularly, for example, the difference between intrusive versus extrusive igneous rocks, and then looking at some of the metamorphic rocks, which I'm not showing here, but are in the resource books. A little note I wanted to talk about was there's another part that's a little bit frustrating in terms of what you're supposed to tell the students. On the left-hand side, and you'll see something that's directly out of the teacher's guide that you're supposed to tell the students when you're talking about the structure of the Earth, that between the core and the crust is the most massive part of the planet, the mantle. So far, so good. But then it goes on to say that the mantle is composed of molten rock material called magma. This is factually incorrect. That is not true. That is not what the mantle is like. In fact, the teacher's guide in the background information clearly states, as is correct, that the Earth's mantle and the crust are both solid rock. Now, the mantle, if you read up on it, or if you have a geology background, the upper portion of the mantle tends to be a little more solid-like. The lower portion of the mantle tends to be a little more of a, I've seen it described as almost like a plastic in terms of its flowability and so on, but it is definitely not molten rock in that sense. There are pockets or places where rock melts, and that is a very important geologic process. It occurs often between where the crust and the mantle meet in the area of the lithosphere, and there's a number of factors that can influence that, such as increasing pressure or volatiles, such as gases and water and so on, which you can go into, and there's information about that you can find. But please don't tell your students that the mantle is magma, because that is not correct. And again, I'm not sure why Foss put that in there. In part 2 of the investigation, students are modeling the igneous rocks that they had been seen before. One of the things students will have noticed when they were looking at the igneous rocks was the presence of crystals. And so you're going to model the process of crystal formation in rocks. And the kit is fairly straightforward, that you're going to take these crystals that are in the kit, transfer a certain amount into these glass jars. But I do want to caution you, please emphasize to students, do not open these jars. These jars that remain closed, they have no reason to open them. They're going to warm them up to melt the crystals that are in there. They're going to cool them at varying rates to observe crystal formation, but they have no reason to open them. And there is a safety note in there that I encourage you to read, because you do not want this to be getting in the students' eyes or for them to ingest them. What's going to happen is students are going to do an investigation. Now, I do want to say that when the students are given these, you have 2 options. You can do a very teacher-directed investigation lab where you tell the students step by step what to do. But there is the option of having the students design their own investigation. There actually is a worksheet for them to use and to actually write their proposal. And if you feel comfortable with that and the students are at that time and you have the time available in terms of your pacing, I would definitely recommend that you try that out. Students are going to take those crystals and they're going to, that solution after it's melted, and they're going to cool them at different rates. And what they'll find is that those crystals, or the solutions that cooled slowly, form much larger crystals than the solution that cooled rapidly. And this is to model what's happening with intrusive igneous rocks, rocks that have cooled in the interior over a longer period of time, versus extrusive igneous rocks, those that cool on the surface of the earth or underwater. At the end is a whole section on neighborhood geology and so on, but I do want to point out a couple of resources I have found very helpful when I get to this section. This is a book that was recommended to me many years ago. But for those of you who know Jack Sheridan, who used to work in the BPS science department, he recommended this book to me, and I love it. It's called Written in Stone, A Geological History of the Northeastern United States, by a father-daughter team, the Ramos, and it gives a wonderful history of why the geology in the Northeast is the way it is, starting back from 4.5 billion years ago up till the present. Highly recommend it. You can find it on Amazon, you can find it in the local library, but it's a very good read and something that helps to kind of boost your background information about why we have a certain geology that we do in the Northeast. This is another resource. It's a website called bostongeology.com. It was put together by some teachers in Brookline along with Tufts University. And it has a link to virtual field trips in the greater Boston area. You can click on these and we'll give you information or give you directions on how to get there, talk about the types of rocks you can find. There is also information about geology and how it affected development of downtown Boston. And then what I found really interesting is, again, there's this whole section on the geology of Boston from 4.6 billion years ago to about 2 million years ago. Some of it's very similar to what's in that book I mentioned before, Written in Stone. But it talks about some specific sections around here in Boston. There's some really good maps that you can look at and show the students. And then there's also a glacial history of Boston. So I would definitely encourage you to take a look at that and check it out. Going towards the end of the investigation, there's a close reading activity and a text-dependent question that you can find on Boston's Weebly site. And if you go to the Weebly and click on Science and Literacy, it'll take you to a whole set of reading activities that teachers in Boston have put together that are all set up for you to use. So for example, here is a close reading assignment for this kit. And this is the article that came with the FOSS kit, Destroying and Reconstructing the Earth. But instead of just answering the questions that came with the kit, we've put together a series of 6 text-dependent questions, meaning the students have to find the answers in the text, not something they're just pulling out of their prior knowledge or anything like that. So it really requires them to go into the text with depth. And there's some strategies that are there on the Weebly site to help you go through that. So it's a great opportunity, and it gives you another opportunity to go into a little bit more information about plate tectonics. That being said, this kit is very weak in plate tectonics, and there's a number of resources out there that I encourage you to look at. There is a video that I have used that I found on Netflix. I unfortunately don't recall the title off the top of my head, and where I am right now, I'm not able to access Netflix, but there are a number of them out there. Some of them are flashier than others. The thing that I find useful is particularly giving a graphic representation, computer graphic representation of what's going on the interior of the Earth and how the Earth's surface has changed over many billions of years, and what drives plate tectonics, the convection currents in the mantle, for example, and drag of a subducting plate pulling the plate along, and so on. So there's a lot of information there, and it's definitely important you go over that because those are in the state standards, and there are questions every year or so on the MCAS that students are responsible for, and that is one gap that this kit does have. So with that, I'll end there. Congratulations, and I hope you enjoy the FOSS Earth History Kit. And again, if you have any questions, please feel free to contact me at the email address that was in the introductory slide at the beginning. Thank you very much.